Hi guys. So we spent the first 3 days simplifying a single fraction, multiplying fractions together, and dividing fractions together. Those are all very similar concepts. You factor and cancel. Today, we're starting a new section, 8-5, and in this section, we're going to move on to adding and subtracting fractions. This is going to get a little bit more complicated because the rules for adding and subtracting fractions are different than the rules for multiplying and dividing. Specifically, when you're adding and subtracting fractions, you must have a common denominator. Today's video is going to focus just on fractions that have a monomial for the denominator. Tomorrow, we'll learn about what to do when there's a polynomial. Here is our first example. When you're adding and subtracting fractions, your first focus should be on the denominators. And your goal is to get a common denominator, otherwise known as an LCD. LCD is the least common denominator. That means the smallest numbers and letters that you can create in every single denominator using only multiplication. Now, least is a little deceptive. It's not necessarily going to be a small number, so we don't want to look at these fractions and say, ooh, 2 is the smallest number. It must be the number 2. Least means of the options available to us, we want to choose the smallest option. And it doesn't necessarily have to be a small number, it just needs to be the smallest number of those numbers available to us. With monomial denominators, we can focus on the numbers and the letters separately. So looking at just the numbers, we need to think of a number that we can turn a 6 into using multiplication, and we have to be able to turn a 2 into that same number using multiplication. And we have to turn the 8 into the same number using multiplication. So what I like to do on these problems is I like to choose the largest number and just go through the multiples of that number until I find a number that everything can be changed into using multiplication. Sometimes it's actually the largest number that you see. So we should check the 8. Now, 8 is not part of the LCD because I cannot change a 6 into an 8 using multiplication. My next multiple of 8 is 16. Now, I can change a 2 into a 16. But again, I can't change a 6 into a 16, so that's not going to work. My next multiple of 8 is 24. And that's it. 24 is part of my LCD. I can change a 6 into a 24 if I multiply it by 4. I can change a 2 into a 24 if I multiply it by 12. And I can change an 8 into a 24 if I multiply it by 3. So part of my LCD will be 24. For your variables, it's actually like the reverse of what we did for GCFs. So GCFs and LCDs are kind of opposites of each other. So we're actually going to take the biggest exponent that we see on each variable, and that's going to be part of our LCD. So for our letter A, I'm going to use an A squared, and then for the letter B, I'm going to use a B squared. So my LCD is 24 A squared B squared. Once you've decided on what your LCD is, you're going to multiply each fraction individually on the top and bottom by the same thing, creating the LCD on the bottom of the fraction. So I already said on the first fraction, 6 times 4 will give me 24, so I'm going to multiply by 4. For my variables, I already have an A squared, but I am missing the B squared, so I will also need to multiply by the B squared. And whenever you multiply a fraction, you have to do the top and bottom by the same thing. For my middle fraction, 2 times 12 is 24. I have one letter A, but I need an A squared, so I will need to multiply by a letter A. And same thing with the B's. I have one B, but I want 2, so I'll need to multiply by a B. So I'm multiplying the middle fraction by 12AB. For the final fraction, 8 times 3 is 24. I'm completely missing the A squared, but I do already have the B squared, so 3A squared. At this point in time, all of your fractions should have the same denominator. That means you're doing good. Don't forget to multiply your numerators. Once you create a common denominator, you can smush all of the fractions into a single fraction, and that fraction will have your common denominator. So once you get a common denominator, it stays the same for the rest of the problem. We do not change the denominator once it becomes a common denominator. We do add or subtract the numerators. All right, at this point in time, I have a single fraction. So this is actually going back to what we were doing in Monday's video. I have a single fraction. It has adding and subtracting in it, so I have to factor. The top can be factored using Xbox, and after I'm done factoring, I get this. I don't need to factor the denominator because there's no adding or subtracting. Once I'm done factoring, I can see that I cannot simplify this fraction at all, and so I would be done with this problem. This is my final answer. Now we forgot something. We forgot to do our restrictions. Anytime that there's variables in the denominator, you have to state some restrictions. You can actually just look at your LCD to figure out what your restrictions are. So in this problem, my restrictions are A cannot equal 0 and B cannot equal 0. And you can write your restrictions as soon as you decide what your LCD is, because that's where the restrictions will come from. This is our only example for today, but just so that we feel a little bit confident before we go into our homework, I do have some that you can try on your own. So when you're ready, pause the video, see if you can do these problems. There's no, I don't even think there's any factoring at all in these questions. So figure out what your LCD should be, create your LCD, and then smush your fractions. When you're ready, unpause the video. All right. For the first problem, my LCD that I got was 20x. They both already have an x in common, and then I can change a 4 into a 20 if I just multiply it by 5. So we multiplied this by 5. So 20x was my LCD for that one. And then for my final answer, I got negative 1 over 20x, because it was going to be like 19 minus 20. And then for my restrictions, I got x cannot equal 0, since x was in the denominator. For the next problem, when I was trying to find my LCD, I just kind of looked at each denominator and I asked myself, what does the other one have that this one doesn't have? So when I'm looking at my first fraction and I ask myself, what does my second fraction have that my first fraction does not have? I tell myself, oh, it has a z. So if I want them to be the same, I better make this one have a z. And then same thing for the second fraction. So what does the first fraction have, but the second fraction is missing? Well, it's missing a letter x. So I should multiply by x. So the LCD on this problem is xyz. That's also going to play into our restrictions. X cannot equal 0, y cannot equal 0, and z cannot equal 0. And then here's my final answer. Now, the numerator does not factor, but it does have a plus sign in it. So I also cannot cancel. So if it helps, you can draw parentheses anytime you have adding or subtracting, even if it's not factorable, just throw some parentheses around it so that you remember, hey, I can't cancel this out because it is trapped in a parentheses. All right, on my last fraction, my last problem for today, I can change a 3 into a 12 if I multiply by 4. And we said earlier, we're going to take the largest exponent on the variable. So I do want them both to have a y to the third, which means that this one needs to be have another letter y. So I'm going to multiply the top also by 4y. And then here is my final answer. Again, on this one, my numerator does not factor, but it is a subtracting problem. So that means it also is not allowed to cancel. And throw some parentheses around it if it helps. This concludes today's video.